The very things we use every day to make life easier are often the result of ingenious design, brilliant engineering and advances in science. A remarkable secret life just waiting to be discovered. Meet Richard Ambrose and Johnny Phillips. They're industrial scientists, fascinated by the commonplace objects all around us. Join them on their mission to unearth the surprising stories behind the things we take for granted. In this edition, paint. Richard and Johnny go to great heights to see how bridges are painted. And meet the man whose job it is to watch paint dry.
Is it dry yet, Keith?
Also, life-saving smoke detectors put through their paces. The explosive story behind airbags. And Johnny's grinder discovers what's inside a trainer shoe.
Here's the thing. I bet you can see some paint from where you're sitting or standing right now.
And I bet every single one of you, every man, woman and child has at some point wielded a paintbrush.
Or a roller. Or one of those little spongy things you use to get a dappled effect or a mottled effect. Or one of those...
In Great Britain alone, we buy 300 million litres of paint every year, which, astonishingly, is enough to fill 120 Olympic-sized swimming pools. It's also been estimated that there are 40 million litres, enough to fill 16 Olympic-sized swimming pools, of unused paint lying around in sheds and garages around the country.
We've all heard of emulsion, gloss and vinyl silk.
But that's not the complete story when it comes to paint.
There's loads of specialist paints out there capable of doing some amazing things, like hiding a plane.
Or even preventing crime.
Honest, Gov.
The military are developing smart paints for use on tanks. The paint is embedded with active microtechnology, which means that if the tanks become corroded or scratched, the vehicles can heal themselves. Equally amazingly, the tanks will have chameleon qualities, the ability to adapt their appearance to their surroundings, making them virtually invisible on the battlefield. The military already use radar-absorbing paint on some aircraft, which makes them invisible to radar. The paint contains a metallic compound which, when hit by radar, creates a magnetic field that dissipates the energy of a radar signal. In some cases, paint can be a real nuisance, like when it's used to daub graffiti everywhere, but a special paint has even been developed to combat that.
To test it, we're going to do some graffiti of our own.
This section of wall has been coated with anti-graffiti paint.
And this section is left totally untreated. Let's go.
The anti-graffiti paint is made up of a base paint and a hardener, which are mixed together prior to painting. They bond so tightly, they create a virtually impermeable clear coating. Graffiti can dry on top of this special paint, but has no means of getting a proper grip, making removal possible.
That's starting to look good. Apart from Johnny's son, it's starting to run. Now, it's taken very well on the untreated wall, but on the anti-graffiti paint, it's beading.
Now, that's because there's an additive in the anti-graffiti coating which rises to the surface when you've applied it and repels the graffiti when it's sprayed on.
This should mean it's easy to clean off, even after days on the wall.
It's all dry.
Yep, I think that's dry enough.
Remember, it's the left side that's treated.
It's just coming off with my finger.
There's no chance this is. That is embedded.
That's amazing.
Let's use some cleaning products. No, this has permeated the wall too thickly.
Look at that.
The paint is even resistant to strong graffiti cleaning fluids. So, while the graffiti comes off easily, the protective coating stays put to repel any further vandalism.
Hey, this anti-graffiti paint's good stuff, Rich. I think that's job done.
That's right, isn't it?
I'm off for a cup of tea.
Johnny.
See you later.
Johnny. Johnny.
Still to come. The boys take up the roller versus brush challenge and then visit one of the largest painted structures in Britain, the massive Humber Bridge.
There are two types of domestic smoke alarm, the ionisation and the photoelectric. In this one, the smoke neutralises ionised atoms in the air, breaking an electrical circuit and triggering the alarm.
Whereas with the photoelectric alarm, the smoke disrupts a constant beam of light on the inside, scattering it onto photosensitive cells, and that triggers the alarm. They're very clever, they're very simple, and they have to work.
Time to see how they're tested. Particles of smoke are tiny. They're about 1/10,000th of a centimetre in size. So technicians here at the BRE Testing Centre spend their days doing a bit of fire starting. The smoke alarms are all fixed to a 4-metre high ceiling, and then the first fire is lit. The European Union specifies the types and sizes of fires used, and each one has to produce a different type of smoke. This one is made from N-heptane, a fuel found in solvents, and it's lit remotely because the smoke is lethal. It burns with a grey colour.
It simulates burning liquids, could be a chip pan fire, or if it was arson, it could be petrol.
The alarms all make a loud enough beep. So for the next smoke test, a fire is made with polyurethane foam. It's like the stuffing in some sofas, but this foam's not heat-treated, so it will burn well with thick black smoke. The alarms have passed again, so it's on to a more difficult test, the cotton wick. These tresses have been dried in an oven, wires are set up around the bottom of them, and enough heat is put in to get them glowing. This makes them smoulder, and soon the cotton wick is pouring out white smoke like a chimney.
You may also get, from a smouldering fire, very white smokes with much less energy, so the smoke drifts up, and the smoke detector has to be able to detect both types of smoke, but also to allow the smoke to enter when there's very little energy. So the design of the chamber has to be adequate to stop spiders and light and things getting inside, but also allow the smoke to get in.
Not all smoke alarms go through tests like these. If you want one that has, you need to look for a certification mark. Only then can you be sure that your alarm will pick up the tiniest of particles and beep like a good 'un.
This is my favourite part of the show because I get to cut things up to show you what's inside them. This time it's a pair of state-of-the-art women's trainer shoes. Time to get cutting. Trainers stopped being solely for sports use by the 1970s and became part of urban chic. Now they're regular everyday wear for many people. It's estimated that annually around 985 million pairs of trainers are sold worldwide. But what's inside that makes this trainer tick?
You should be a trainer.
There are 4 layers between your foot and the ground. There's an insole, a stiff nylon layer, a shock-absorbing midsole, and an outer sole made of carbon and rubber compound. Unlike many shoes, the soles of these trainers continue much higher around the toe area and up behind the heel to minimise wear on those areas of the shoe. But here's something I wasn't expecting. This disc in the heel. Sports scientists discovered that most women walk in a different way to men because they have a wider pelvis. Women tend to walk on the inside or the outside of their feet. The disc helps to correct this tendency and makes for a more comfortable and balanced walk. More grinder action next time. I can't wait.
Don't go away or you'll miss Richard and Johnny going to great heights to show you how this bridge is painted.
If you could.
And the explosive story behind the airbag. Now back to the fascinating world of paint.
Generally, all paints are made of 3 basic ingredients, and we're going to mix them up to show you how it's done.
Now, the first ingredient is pigment. We're going to make some blue paint, and there's a little bit of pigment for you.
Then there's the binder, which will bind the pigment to whatever you end up painting. There we go, look at that.
Nice one.
It's like treacle.
And the last ingredient is solvent or carrier. Now, this thins the paint down, makes it easier to apply, and also, this is the stuff that flashes off and leaves the paint solid behind.
In domestic use emulsions, the carrier is nothing more complicated than water.
It's a nice colour.
It's gorgeous, isn't
Should we do your front door with that?
It simply evaporates once the paint is on the wall. In oil-based paints, like traditional gloss, the carrier is white spirit, and that again evaporates once it's exposed to the air.
That feels like proper paint.
Really, really high-quality paint as well. Look at that. Look at the way it's just immediately stuck. See that? Beautiful.
Commercially produced paints are mixed in batches of anything up to 40,000 litres at a time and can have up to 30 different ingredients in them. They use a blend of many different pigments to achieve exactly the right colour. Then there are various other ingredients such as preservatives and thickeners. The trick when mixing an industrial-sized batch of paint is to make sure that every time you make a particular colour, it's the same as the last. Whilst the ingredients remain the same, the mix alters slightly each time because pigments vary in strength. Some manufacturers do this by computer, others by eye. And it's a bit of an art. Creating a commercial paint is done in stages and can take up to 8 hours, a whole working day.
Oriental blue. Delightful. Now, you know, at this point in the programme, Johnny and I like to do a hands-on, action-packed demonstration. Well, we've got a real showstopper for you this week. We're going to watch paint dry.
This is Keith. He's the technical manager at this paint manufacturer, and part of his job is actually watching paint dry. And he's going to show us how he does it.
We've got 2 paints here, haven't we, Keith? One's
That's right, yeah.
your competitors and one's your newly developed paint.
That's the one. This is the competitors.
OK. And this is your...
This is our newly developed.
Your own blend.
Faster drying coating.
OK.
So we just simply draw it down.
And now we just
wait for them to dry.
How do you know it's drying?
Well, at the moment what we're doing is we're just checking it to a tack-free stage. Later on we can go into more sophisticated ways of through-dry, dust-free, things like that. But at the moment we're just doing a tack-free.
So it's literally just touch?
Touch dry, yeah.
Developing a faster drying paint than your competitors can give you a market advantage. Manufacturers do this by adding a catalyst to the binder in the paint, which helps it dry quicker. The exact proportions of this and other chemicals in the paint are closely guarded industrial secrets.
Is it dry yet, Keith?
I don't know, it's looking... Oh, yes.
Did we win?
Yeah, this one's still got big tack on it.
Well done.
And that one's dry.
And on that note, we'll leave paint alone for a few minutes, but we'll be returning for a third coat because later on, Richard and Johnny have a big job on their hands.
Airbags. The idea of using a giant balloon to cushion you if you crash has been around since the 1950s. Yet it wasn't until 1974 that General Motors offered the first commercial car with a driver's side airbag. Today, all new American cars and 91% of all new European cars are fitted with airbags. Your driver airbag works in a very similar way to a rocket. They both use solid fuel. In your car, this is found in a compartment behind the steering wheel, like this. When it's ignited, it's contained and the gases released inflate the airbag. Whereas with a rocket, the solid fuel is at the bottom. So when you ignite it, the uncontained release of energy propels the rocket skyward. The gas blows up the airbag pretty quickly, so we're going to film this test rig to show you just how fast it inflates. That yellow weight up there simulates somebody's chest. Now, as it's dropped, it will pass this sensor, which will activate the airbag to inflate in time to cushion its fall. Well, Rick, that happened so quickly. What speed was that?
The airbag's inflated in roughly 35 milliseconds, which, to scale it for you, it takes you approximately 200 milliseconds to blink.
Wow.
Which is pretty
Now,
quick.
that's why I didn't see it.
Yeah.
You don't need to worry about suddenly being hit by an airbag. because a sensor in your car continually measures acceleration and deceleration. It'll only deploy the airbag when it senses a dramatic deceleration resulting from a sudden impact. And the bags themselves are getting clever. They can now alter the amount they inflate according to the weight and position of the person, which means they're less likely to give you a hard punch in the face. So how do you make a bag that can do all this? Bags are actually constructed on the loom because the fabric is woven with two sides, and it's here that red seams are put in, which can tear to adjust the bag's inflation. Once off the loom, the fabric is washed, dried and coated.
Now this roller is actually liquid. It's pure silicone. Look at this. Most airbags are coated with silicone to make them more airtight and to give them a degree of heat proofing.
Lasers and small rotating blades are used for the perfect cut. And every single bag is checked for defects before the holes for the inflators are put in and they're folded into shape.
Now check this jacket out. It can surround you in airbags. It's already being used by some of the police riders in Japan, Spain and Brazil. And the idea is that if you're on your motorbike and you get thrown off, this tag gets pulled, the jacket inflates and it can soften your fall. Now it needs a damn good pull. Darren, if you could. Now it improves your safety and it's pretty damn sexy too.
In today's cars, airbags can be in the roof, in the side, in your seat. There are even airbags to put you in the right position before you hit another airbag. But wherever they are, an airbag will always react so quickly that if you blink, you'll miss it.
Now, Richard and I have a lot of fun playing these guitars, but just how are they made?
In this workshop in Northern Ireland, they make acoustic guitars using many methods first used 100 years ago. Guitars are made from 8 or 9 different types of wood, and it's the main body that gets built first. The pieces of wood are glued together so that the grains mirror each other and are secured with straps to make sure they stick together properly. Once the glue is set, the shape of the body is cut with a fine saw. The neck of the guitar is made from layers of solid wood with an ebony plate over the top. The basic shape is cut out and then a drill makes 6 holes where the machine head will go. A row of small circular saws cut grooves into the ebony plate, making slots for the frets, which are the metal inlays that make the guitar able to play various different chords. And finally, it's clamped into a vise, and the edges are smoothed and rounded off. The strips of wood that make up the sides of the guitar are hand-bent using a heated iron at 160 degrees Celsius. It can take an hour and a half to hand-bend one side of a guitar. Once bent, they're clamped into a custom-built mould and left to set. Small pieces of wood are glued to the inside of the guitar. These are called struts, and they add strength so that it can withstand the constant pulling of the strings. A vacuum press sucks all of the air out, and the struts are carved by hand to give the guitar its individual sound. Then they go over to the guitar mould, where the completed body is left to set. The neck of the guitar is carved by hand, and once this is finished, the 2 pieces of the guitar are ready to be glued together. Nickel and silver alloy are used to make the frets, which are hammered into place on the ebony plate. And the guitar gets sanded, and 10 coats of lacquer are applied to give it a beautiful finish. Now all that's left is stringing. Once the bridge is glued on and the machine heads are screwed in, the strings, made of phosphor, bronze and steel, are threaded and tightened. A gig at the pub or into the hands of our 2 favourite virtuosos. Now it's time for this show to get its final coat of paint. And for Richard and Johnny to ask the question that's vexed anyone who's redecorated their house.
Paintbrush
Or roller?
Ready, go!
An ancient paintbrush survives from 30,000 years ago. It was used by a cave artist. The bristles on modern brushes are either synthetic or made from the hair of animals, including horses, squirrels, hogs, oxes, badgers and goats. A well-made 2-inch brush can have 8,000 bristles. The absorbent material on most rollers is produced from man-made fibre, such as polyester or acrylic. However, many rollers for outside painting are made of sheepskin. In our test, it's Johnny and his speedy roller that win.
Damn! Painting your house using a roller or a brush takes a heck of a long time.
But imagine painting by hand something this big.
This is the Humber Bridge, and it's over 2 kilometres long. When it was first opened in 1981, it was the longest single-span suspension bridge in the world. Everything about this thing is massive. It weighs over 500,000 tonnes, and the suspension cables that carry a lot of that weight contain over 71,000 kilometres of wire. That's enough to stretch around the world 1.5 times.
Now, painting this bridge isn't just a matter of making it look pretty. Out there is the North Sea, and down there in the estuary it's salt water, making this an extremely corrosive environment. So every single metal surface that you see, from the railings here, up to the ladder and gantry there, to the cables supporting the bridge, have to be protected.
So this isn't just paint, it's a paint system. It's intrinsic to the design, the construction and the maintenance of this entire bridge.
The paint used is actually rubber-based, and it's put on in 4 coats. But once applied, the coats all combine to become one very tough, very weather-resistant coating that's capable of lasting for up to 7 years. Without that protection, the cables would rust through in just a few years. With that protection, this bridge should last into the next century. All the painting is done by hand. And when you're talking about over 80 acres of painted surfaces, you're talking about a big job. Right now, they're touching up the railings, resealing the bits that have worn through or rusted. And guess how long it takes to do just the railings? 3 years.
Now, the reason it takes so long is down to the good old great British weather. When it's raining, these guys can't paint, so it restricts the painting season down from April to September.
And even in the summer, when the wind gets up, they can't paint, because as soon as they take the brush out of the pot, the wind whips the paint across the road and onto cars, which can lead to some pretty irate drivers. Now, as well as all the railings and cables up there, the whole underside of this bridge also needs painting, which is a huge surface area requiring an enormous amount of paint.
And we're talking tons upon tons, so amazingly, when this bridge was designed, not only did they have to make sure that it could take the weight of all that traffic, but also the weight of all that paint.
One final thought. After this show, take a look around you and count how many things are painted. You might be surprised. Join Richard and Johnny next time for more stories behind everyday objects.
We've all heard of emulsion, gloss and vinyl silk.
Did it?
Keep pulling, keep pulling, keep pulling, keep pulling, and cut there.